Okay, our our next speaker comes to us from Iowa State. Just finished her master's, Rabsa Naseer, and she's working currently in the ISU VDL Bioinformatics, and is going to speak to us about emergence and dissemination of PRRS variant L1C.5.32 across the state of Iowa.
All right, testing. Okay. So today I'll be talking about the emergence and dissemination of a new PRRS variant, L1C.5.32, across Iowa, and we'll see a couple other states as well. So just a very quick general overview of PRRS for those who don't know. It's a very costly virus, just economically, over $1.2 billion in losses. It causes reduced growth and high mortality in pigs. The RNA virus genome is 15,000 bases and has 7 open reading frames. So like Dr. Poplawski said, we will be focusing here on OR5 that is used for lineage classification and is a very diverse segment. It's a very persistent arterioviridae virus and very challenging to eradicate. This work focuses on PRRS2, which is the North American variant. It infects porcine macrophages, which are the immune cells, causes immunosuppression and prolonged viremia. In sows, it causes abortions and stillbirths, weak piglets. It can also cause fever, anorexia, respiratory distress. It's thought that most of the spread of PRRS is due to animal movement and global trade. So today I'll be talking about the L1C.5.32 variant, but before it was declared a variant, we decided to call it a clonal expansion. So there's been an increase in detections of L1C.5, that sublineage over time in general. And here we see a tree from PRRSV, ISU PRRSV. This is a publicly available website through ISU, or Iowa State University, that has a set of different bioinformatics tools available for use. And here we're looking at a tree that includes just 1 month's worth of sequences from this year. And what we see is these are all the L1C.5s, this reddish pink color. And what we saw was this formation of a separate clade at the top of the tree. And the branches here are very short, indicating that they're very similar. So we find very genetically similar cases of L1C.5 over time. And this was later known to be L1C.5.32. But today I'll be talking about kind of how we got to that variant classification. So originally what we did was we found one of those very first cases from that clade, and that was from July 20th of 2023. And we pulled data available through ISU VDL from January 2023 to February of 2025. So that was just the period of this study. And then we classified the lineage and sublineage through NextClade. So NextClade is another publicly available tool that uses a PRRS reference set that's been curated by ISU researchers. And then using maximum likelihood phylogenetics, we identified those clonal sequences. So our index case is somewhere in here. And basically anything within that clade was considered to be clonal. And we see, again, those shorter branch lengths compared to the rest of the L1C.5s. And these shorter branch lengths are something we usually just see with vaccine strains, so like within MLVs. We see those shorter, very similar branch lengths. And so this was kind of confusing to see with L1C.5. However, now you can use PRRSloom, which is a tool through Van der Waal UMN that you can use to classify that variant status. So at this time, .32 was not yet existing, so we couldn't use that just yet. So moving forward, we kind of wanted to look at the .32 or clonal sequences compared to non-clonal. And so for the period of this study, we saw that there was an increase since that index case of L1C.5.32 cases, reaching almost 50% or more of the L1C.5s over time. And then it's kind of been floating around that 30 to 50% mark since then. This is a figure from the SDRS, the Swine Disease Reporting System that ISU VDL is part of. So this is using data from, I believe, 7 different VDLs, and this figure was thanks to Guilherme Caesar with ISU. And what we're seeing is, again, since that index case through July of this year, we're seeing, again, just an increase slowly. And we're seeing it in both adult sow farms as well as wean to market. Looked like it might have started in wean to market, but we're seeing it pretty heavily in both types of farms. Next, we wanted to see how CT values compare between the 0.32 variant as well as non-clonal L1C.5s, and then 2 well-established PRRS lineages, L1A and L1H. Here we're looking at 3 separate charts. These are for lung, oral fluid, and serum. So some other work we've done, we see that there are significant differences in the ranges of CT values between specimen types. So if we just take a look at, for example, serum here, we're seeing that the L1C.5 in that reddish color, or 0.32 variant, does tend to have a lower CT value and range, both in range and median value compared to non-clonal L1C.5s, as well as those established L1A and L1H lineages, and that's consistent with oral fluid and lung as well. Next, we took a look at the effective population size. So this is measuring the diversity. This is taking alignment data and measuring the diversity of a population. So in the blue, we have our non-clonal L1C.5s. In the red, we're seeing our L1C.5 0.32s. So using that alignment data, we're looking at basically the number of unique, genetically unique individuals. So even though there may be an increase in the number of detections, we're just looking at how many of those detections are actually genetically unique. So we see since its emergence, L1C.5 in general had an increase in diversity and then a slow decrease. We're seeing the same thing with the 0.32 variant, almost kind of a stagnant low diversity. So we're seeing kind of a general decrease in diversity for L1C.5 and 0.32. Next is reproductive number. So given one detection, how many subsequent detections are we estimated to get? So a value around 1 is indicating that it's not really increasing or decreasing in detection, it's kind of stagnant. So for comparison, we have again L1A and L1H, and even our non-clonal L1C.5s are kind of hovering around that value of 1. But in that reddish color, again, we see 0.32 variant showing some peaks here, some increases in that reproductive number. So together, what we're seeing is a decrease in the diversity and an increase in the reproductive number, and that together combined is the perfect mix for a clonal expansion. So we're seeing low diversity, but an increase in those detections. We also measured genetic distances within different lineages and between different lineages, and this is something that we ended up doing to kind of help out with that classification of the new 0.32 variant. So what we're seeing here is within, again, L1A and L1H, those established PRRS lineages, we're seeing a genetic distance within the clade of 0.1 and 0.07. And this is basically measuring between sequences the amount of substitutions we can expect. Within L1C.5 as a whole, including those 0.32 variants, as well as non-clonal, we're seeing 0.04. And then the clonal sequences of 0.32 have very little diversity within very little genetic distance, so 0.01. And notably, we're seeing the diversity or distance between the non-clonal L1C.5s and clonal 0.5.32 has a greater genetic distance and variation than just within the L1C.5 as a whole. Next, I'm sure you're curious, is where we started to see these cases and where maybe they are going. So most of Iowa here, you can see, has seen some of these 0.32 variant cases, heavily in the bottom right quadrant, southeast Iowa, which is, I believe, consistent with some production systems as well. Our index case is here in Hardin County, which is considered northeast Iowa for this study. And then moving forward, these are our 4 different quadrants. and where is it going? So here I have a chord diagram. So this is kind of showing the visualization of the movement of the .32 variant between the quadrants of Iowa and to the neighboring states. So if we look here, we have a very thick arrow from northwest Iowa to northeast Iowa. The thickness of the arrow is indicating the likelihood of this event occurring. So we see with very high likelihood, there's movement from northwest Iowa to northeast Iowa. Now this kind of makes sense if you consider that in northeast Iowa it was our index case, and there's a lot of finishing farms in northwest Iowa. So perhaps we saw movement from northeast to northwest, and from there, further movement. We also see movement from northeast Iowa to neighboring states like Illinois, Indiana, and Minnesota. And then here we have kind of the computational or statistical view of that. So we see again, based on log Bayes factor, there's pretty high confidence in movement from northwest Iowa to northeast Iowa, northwest Iowa to southwest Iowa, et cetera. So we're seeing a lot of movement within Iowa and then to neighboring Iowa states. And then another update from the SDRS. We currently see L1C.5.32 in all of the major production states, swine production states, except for North Carolina. So we see most of our cases in Iowa, but we're seeing them kind of spread north and then spread all the way as far as Texas and as far east as we see here. And then to see where it's going, here we have a maximum clade credibility tree that is going to help us kind of estimate where it moved and when. So at the base of the tree, we see it's estimated to have started in the middle of 2025, or 2023, excuse me, which is consistent with the index case. And then we see quick movement to northwest and southwest Iowa. And then our first movements out of state, kind of when that color changes, a little hard to see, was out of state to Minnesota and Illinois. So in general, we're seeing an increase in both the L1C.5 cases and .32 cases, and lower CT in those .32 cases compared to non-clonal L1C.5. We're seeing an increase in that reproductive number, so the estimated number of detections over time, and then a decrease in the diversity, together making that clonal expansion kind of evident. We're seeing movement within Iowa and to neighboring states, and a bit further than that at this point, and a very quick domination of Iowa, likely due to higher transmissibility. So hopefully monitoring CT values alongside some of this genetic surveillance can help improve detection and control of those emerging strains, because at this point, that's kind of all we can do is do our best to kind of get on top of these things. With that, I'd like to thank my mentor, Dr. Zeller, as well as Dr. Trevisan, Dr. Gauger. My contact information is there as well. And with that, I'll take questions. We didn't look as closely at to what kind of movement it was. This was kind of estimated just based on
Virus.
yeah, not just virus, but also the metadata that's provided when submitted to the VDL. So this would just be, it could be the state of collection. Most likely that's all it was at. But yeah, we don't have a ton of consistent metadata regarding what kind of movement it is. Otherwise, it'd be great to be able to involve those kinds of variables.